Okay, this is question number 6, and again, just like question number 2, actually this one is a lot like question number 2 in that what's happening here is when you change the current through this transistor on the left side, VBE stays constant, so VCE just changes the amount that the current requires VCE to change. But over here, since the current changes, it actually reduces VBE. Let's say you increase the current, it reduces VBE, which means your VCE has to move even more, and V out moves more, so it's more gain. So let's start with saying, let's look at the right side. So if V in goes up, then current through V in transistor goes up, and if the current through the V in transistor goes up, current through the V bias transistor, we're on the right circuit on the right again, goes up. Oops, I guess I've got to copy that. Current through V in transistor goes up. That makes the current through the V bias transistor go up. And it has a second effect, which is current through R goes up if current through R goes up, then VE of top trans goes down. Since the voltage across the resistor goes up, the voltage at the emitter of the V bias transistor, so V bias transistor VE goes down, and but once again, I'm going to do the two things that happened here. Now the current through the V bias transistor went up, and to the VE of the V bias transistor goes down, and actually I should have put a step in there, but the step would have been that VBE of the V bias transistor decreased. So this node, the emitter voltage went down because the current went up, which decreases VBE, but the current through the transistor went up. So again, you have VBE going down, but the current going up, and this transistor says, wow, I got to accommodate that new current. My VBE went down, so I have to change my VCE even more than I did before. So when VBE, like over here, VBE doesn't change on the V bias transistor. So when you change the current through it, the VCE just changes enough for that current. But over here, because VBE went down and turned down, which usually turns down the current, this VCE has to increase even more than it does on the left-hand circuit to accommodate the new current. So So the current through the V-bias transistor goes up, but the VBE of the B-bias transistor goes down. So what happens is VCE of the V-bias transistor needs to move even more, which means when the VCE changes here, when that has to move even more, that means that V out moves even more, and that equals more gain. I could have written this a little fancier, but a little cleaner. But the goal is, if you get these two results, then from those two results, now it means that V out has to move even more.